Now, in order to implement the KNN, we first need to understand what is the KNN. What do we mean exactly by the KNN? As we said, KNN is short for K nearest neighbors. So looking at these three pictures, we can understand better how the KNN algorithm works. So let's say we have these circles, and here we have some triangles, okay? So this is label 0, for example, and this is label 1. And this is, of course, the training data. Now we have a new test data, and we want to decide for this new point if it's a circle or if it's a triangle. So how we can do so? We calculate the distance between all the training data and the test point. So this is a test point. We will calculate the distance between this test point and this point, right? This training point and this training point and this training point. So we will calculate the distance between the test point and all the training data. After that, we will find the K nearest neighbors. So let's say we decided that the K is 3. Okay, so we will calculate the 3 nearest neighbors. So this, and this, right? And finally, we will classify this point based on a majority voting. So this is a circle, this is a circle, we have 2 circles, and we have 1 triangle. So based on this, this should be a circle. So this is basically how the KNN algorithm works. Okay, it's very, very intuitive, very easy to understand, and as you can see, it's a non-parametric model. We didn't really talk about any parameters because, as you can see, it's based on the data itself. If, for example, we have 2 triangles and 1 circle, then this point will be a triangle, right? So this is how the KNN algorithm works. Now, in the next lesson, we will see how we can implement the KNN algorithm from scratch. We will see how we can use Python to implement step number 1, step number 2, and step number 3, and then try on the iris dataset to classify the test points. Okay, so let's go.